50 years ago, humanity entered a new era, when two heroic explorers took a small step into a new world. It was a massive technological achievement. Aside from the breakthrough itself, it spurred innovation in agriculture and medicine, business and consumer products. And in a strange way, it brought us all a little closer together. I'm talking, of course, about spreadsheets. 1969 was the year that Remy Landau and René Pardo came together to form LAMPAR Technologies. As well as being a play on their names, LAMPAR is an acronym. It stands for the Language for Programming Arrays at Random, and it had a lot of the features that we associate with modern spreadsheets, most notably forward referencing, or as we call it, reactive programming. And you've all experienced this, but I'm going to show you anyway. I have a spreadsheet here that tracks my fruit purchasing habits, and in columns B and C I have some values. I've got some prices and I've got some quantities. In column D I've got something more interesting. I've got formulas. The values of these cells are derived from the values of other cells, which means that if I buy another cantaloupe, the spreadsheet updates automatically. The subtotal and the total update to reflect the new inputs. And the way that this works is the spreadsheet maintains a dependency graph internally, and we can visualize that. We can click around and we can see the inputs and the outputs for each of these cells. And we can even change a dependency graph by adding a new formula. All of a sudden, these cells now have two outputs. Now, this was important back in 1969 because computers weren't very fast, and it's a lot more efficient to only update the things that have changed rather than re-rendering everything. But LAMPAR wasn't destined to become a household name. It was too far ahead of its time, and instead it became a footnote in the history of computers. Nowadays, when we think about the first electronic spreadsheet, we think about VisiCalc. VisiCalc was a huge deal. Steve Jobs credited VisiCalc with the success of the Apple IIe pictured here. But VisiCalc didn't use forward referencing. It took a far more naive approach. Every time you changed the data in one of your cells, you had to go cell by cell, updating all the others. And it was pretty slow and clunky. People didn't mind, they didn't know any better. But it meant that when Lotus 123 came along, which did implement forward referencing, spreadsheets suddenly became so much more capable. You could use them for more things. And in a very short period of time, VisiCalc was all but forgotten. My name's Rich Harris. I am a graphics editor at the New York Times, and this talk is called Rethinking Reactivity. It's a talk about how we can apply the lessons of our forebears to build software that is a little bit less VisiCalc and a little bit more Lotus 123, and I hope you enjoy it. What is reactive programming? Well, as Michelle said yesterday, there are as many definitions of reactive programming as there are reactive programmers. So to make it simple, I just stole his from his slides. The essence of functional reactive programming is to specify the dynamic behavior of a value completely at the time of declaration. In other words, reactive programming is all about data flow. It's all about tracking values through your application. When a value changes, your application should react. We've talked about React a lot at this conference already, and we're going to talk about it a little bit more. React is a miracle. It changed everything. Whether you use it or not, you've probably been influenced by the patterns that React introduced to the web programming community. And since it was released in 2013, the React team has crushed it year after year, helping us solve problems that we didn't even know that we had. But I think we can do better. I think we can do a lot better, and this talk is going to be about how. Now, I know that in the JavaScript community we tend to get a little bit uncomfortable when we criticize each other's work, especially when a React contributor is sitting right in front of me. Sorry, Brandon. But I think it's really important for our collective growth. And if you look back to the early days when React first came out and React advocates were giving talks at conferences, they were very, very critical about the frameworks of that era, and rightly so. I'm going to continue in that proud tradition. React was the first library that used a virtual DOM. And we're going to talk about how virtual DOM libraries work. A lot of you might already know what this code does, but let's talk through it anyway. This is a simple React application that has a single component called app, and it has some local state, count and name. And it has two functions that change that state, handle click, which uses set count, and handle input, which uses set name. And then at the bottom, it returns a slice of virtual DOM. And as that state changes, that virtual DOM is regenerated each time, and then React's job is to reconcile what came before with what came after. So let's see what this process looks like. First, we look at the top level element. It was a div, it's still a div, so we keep it. Then we need to look at the attributes. It had a class name, app. It still has a class name, app. So we keep it. Then we look at the children. It had an H1. It still has an H1. So we keep it. Then we look what's inside the H1. Some text. It hasn't changed. We keep it. Look at the input. It's still an input. We keep it. The value hasn't changed. We keep it. Look at a button. It's still a button. We keep it. Its text has changed. So we need to apply that to the DOM. All that work to change a 4 to a 5. As engineers, we should be offended at all that inefficiency, but that's not the bad part. The bad part is that we keep running this code over and over again. Every time there is any state change at all, we need to redeclare these functions that close over that local state. The problem here is that React doesn't have any understanding of the values flowing through your app. It treats it as a black box. In other words, by any reasonable definition of the word, React is not reactive. Or as John Lindquist said, React is a terrible name for React.js. So is the virtual DOM fast? No, it's not fast. Is the virtual DOM fast enough? Well, that's a more interesting question. I work with data visualization and animation, and I would say categorically, no, it is not. But you don't need to take my word for it. We can ask the React core team. The React core team don't think that the virtual DOM is fast enough, and I know this because they've given us things like should component update, react.pureComponent, use memo, and use callback. These are all abstraction leaks that let you, the programmer, tell the computer that it doesn't need to worry about this subtree within your application. In other words, you're doing the computer's job for it. Another sign that the virtual DOM isn't fast enough is when we start to develop amortization strategies like concurrent mode, which we'll talk about later. So a few years ago, I was thinking, what can we do about this? I want my users to have a fast application. I want them to have a good experience. But I want to have the experience of using a declarative component framework like React. And then it occurred to me, maybe we're thinking about frameworks all wrong. A framework doesn't need to be a thing that runs in the browser. Frameworks are not tools for organizing your code. They are tools for organizing your mind. So given that, maybe the framework should be a thing that runs in your build step instead. Or as Kyle was enthusiastically saying yesterday, compilers are the new frameworks. And so I started a project called Svelte. And this is what it does. It takes your declarative components and then it turns it into the efficient, imperative, low-level code that manipulates the DOM directly. The interesting part here is changed. How do we figure out what changed? Now, frameworks have solved this problem in different ways over the years. Old school React with classes had this.set state. You pass it some new state, it merges it with the old state, and it triggers a re-render. In modern React, we use hooks. We call the setCount function, and then it updates its counterpart, the count variable. In old school Svelte, we had something very similar to classical React. This.set instead of this.set state. That also triggers a re-render. And that's fine. It works. But the trouble is, this.set state and this.set, they're kind of verbose. It's a lot of work to do just to update some state. The thing that they have in common, the problem that they have in common, is the this. As soon as your API depends on a this, you introduce all sorts of constraints that are a little bit difficult to anticipate at first. And so we wanted to improve upon that. Let's take a step back. How do we tell the computer something changed? Well, there's actually a really good answer for this already. We use an operator. Specifically, we use the assignment operator. We declare a variable, and then we say count equals count plus 1. Or more concisely, count plus equals 1. And to give credit where it's due, Vue figured this out a long time ago. In Vue, you trigger updates by assigning to properties. This.count plus equals 1. Now, the way that that works at runtime is very different. It requires that you have a this, which has the problems that we were trying to avoid. So that won't work for us. Those are just the rules of JavaScript. But we're a compiler. We don't need to play by everyone else's rules. So we are days away from the release of version 3 of Svelte, or if you're watching this on YouTube, hopefully it has already been released. And Svelte 3 is different. Svelte 3 moves reactivity out of the component API and into the language. And I'm going to show you what that looks like. This is the same application as before, implemented in Svelte. Up here, let name equals world instead of use state, let count equals 0. And then we've got some similar functions, except this time we update this count variable by assigning to it count plus equals 1. And I can type in here, like that, click the button, and the application updates accordingly. And how does this work? We go to the compiled output and look at the code that the compiler has generated. we'll see that it's actually left our code more or less intact. It's just instrumented it with these calls to the invalidate function. Every time you assign to a variable that is used inside your component's markup, it calls invalidate. Invalidate's job is to say to the component, this value has changed, be aware of that when you update, and by the way, you need to update at the end of the event loop. We can actually get a little bit more efficient here. In Svelte, we don't need to use event handlers just to sync values between an input and a variable. We can use the bind directive, get rid of that. And we can make this an inline function. And get rid of that. And this continues to work as before. Now, an interesting thing about doing it this way, putting JavaScript in our HTML instead of putting HTML in our JavaScript, is that we can compile it to different outputs depending on the needs that we have. So far, we've been looking at a JavaScript class that updates and manipulates the DOM, but we can also do server-side rendering. In SSR mode, all we're doing is concatenating a string, and this is orders of magnitude faster than creating a component tree and then serializing it. What this means is that if you do server-side rendering with Svelte, your AWS bills will be lower. Tell your product managers. How you use it is just like any other JavaScript module. You import it using the import keyword. Once your bundler is using the Svelte plugin, this gets converted on the fly into a JavaScript class. In the client, you just call new app, and then on the server, you have a different API because you're just serializing HTML. You call app.render. But we're not reactive yet. Because in most components, you will have state that is derived from other state. Just like in our spreadsheet, we have cells that are derived from other cells. And the way that this is dealt with in React is, well, they don't need to because the code runs over and over again. So if we have a list of to-dos here that can be done or not done, and if we toggle them by clicking on them, and if we can hide the ones that we've done already, then we can generate that filtered list of hidden to-dos or unhidden to-dos using const filtered, and it will just regenerate that each time. And then down here at the bottom, we have a list that maps over the filtered array. That's not ideal though, because we might have this component inside another component, which means that that filtered variable keep getting regenerated unnecessarily. Its dependencies might not have changed. So in React, what we do is we wrap that in useMemo. And we pass a second argument, which are the dependencies of filtered, in our case, to-dos and hide done. And what useMemo does is it compares the variables in the second argument with the values in the previous run, and if they're unchanged, then it knows that the return value is unchanged, and it just gives you back the cached value. And that's a bit more efficient, but it's obviously more work for the developer. It's more boilerplate for us. If I zoom out so that we can see the entire React component. This is the Svelte equivalent. It's a little bit leaner. And this is something that we see quite a lot. I've converted a lot of React components to Svelte components, and typically what you find is that the React component is about 40% larger. You have to type 40% more code to get it to work. But the trouble here is that this doesn't actually work, right? I'm clicking on these items, but they're not toggling. And that's because this code only runs once. Const filtered. It's a const, so it can't change. We need to find some way of telling Svelte that this is a reactive value that depends on other reactive values. And for that, we need to look for inspiration in the outside world. Speaking of inspiration, I find this guy pretty inspirational. Mike Bostock. He's the creator of D3 and is also the creator of Observable. Is anyone familiar with Observable here? Great. This is a hugely popular tool in the data viz world. It's an interactive notebook generator, similar to RunKit or Jupyter in the Python world, things like that, except it has a key difference. Rather than running your notebook from top to bottom, it runs your code in what's called topological order. This is a fancy way of saying that if statement A depends on statement B will run first, regardless of the order in which they're declared. In other words, it functions like a spreadsheet. Well, we like spreadsheets. Maybe this is an idea that we could use in our components. There's a blog post I like by an Australian developer called Paul Stovell, What is Reactive Programming? And it tells the story of some code anthropologists from the year 2051 looking back and struggling to understand the code that we wrote today. var A equals 10, var B equals A plus 1, A equals 11. Well, then we need to say B equals A plus 1 again. The relationship between those two variables isn't fixed. But in 2015, we have the destiny operator, var b destiny a plus 1. Now, if we change the value of a, the value of b changes with it. They are bound. It's explicit, a part of the language. Could we use the destiny operator in JavaScript? Well, no, we couldn't. It wouldn't be syntactically valid. And that would mean that we couldn't use parsers, we couldn't use linters, all of the other things that are really valuable. But it turns out there is a piece of syntax that we can use. And it's a piece of syntax that almost no one has ever encountered, let alone used. Does anyone recognize this? This is a thing called a labeled statement. And it doesn't really do anything most of the time in JavaScript. So we on the Svelte team have co-opted it. We've made it our own. $b equals a plus 1. B is now bound to the value of a plus 1. I'm the guy Kyle Simpson was trying to warn you about. So we can add that to our original component. Just go down here to const filtered and change it to $filtered. Hey presto, it's reactive. That's kind of handy. And we can go further. We can say showing equals filtered.length and start to have reactive values that depend on other reactive values. Showing of todos.length. And then now, if I start to toggle these, it updates automatically. We're not limited to declarations. Thank you. We're not limited to declarations. We can also have arbitrary statements in here. So we can do this kind of thing, which is very useful for debugging values as they change. All right, so how does this work? Well, if we look at the JS output from this, and scroll down to where it's updating the reactive values. It's taken these statements and it's wrapped them in if statements. If change.hideDone or change.todos, then we recalculate filtered and we invalidate filtered. And you'll notice that because it's figured out that showing depends on filtered, it has to calculate filtered before it calculates showing. That's the topological ordering that Mike Bostock was talking about. And this is all extremely fast for the browser to run. This is very efficient code. Now, a lot of people, when they see this for the first time, they're like, I'm not sure about that. That's a little bit magical. And they don't mean magical in the good way. They mean the bad kind of magic. Evan Yo, the creator of Vue.js, said, well, this isn't even JavaScript. This is technically Svelte script. And he's right. We are abusing the language for fun and profit. But I find it a little bit odd that Evan, of all people, is the one saying this when he, perhaps more than anyone else, more even than Michelle, has popularized the idea of assignments having side effects in JavaScript. The distinction that he draws is between magic that happens in the browser and magic that happens at compile time. I think this is an arbitrary distinction. I think if you draw a line between those two things, then you're guilty of making the same mistake as people who used to say that templates and styles and JavaScript should be in separate files even though they relate to the same component. What matters is the functionality, not where the functionality happens. Something I like to do when framework authors release benchmarks showing how fast their framework is, I add Svelte to it and then I tweet out the result. It's probably why I don't have many friends, but it's so worth it. Because look, this is an old one, and it's showing that Svelte is 35 times faster than React and 50 times faster than Vue. Dan on the React team thinks that this benchmark is meaningless, and I kind of agree with him. There is no point updating your application hundreds of thousands of times a second if your refresh rate is 60 hertz. Dan thinks that we should be measuring user experience instead, and I agree. But he says that we should be, well, he doesn't say that we should be, but Dan is talking specifically about something called concurrent mode, which is a feature that is coming to React soon. And we need to talk about concurrent mode. And the best way to do that is to use one of Dan's demos from a previous conference talk. Many of you have probably seen this. This is from JSConf EU Iceland. If you haven't seen this talk, I really do urge you to do so. It's an incredible talk that really changed a lot of people's understanding about how this stuff works. So if we start typing into this input, this is React today. Now, maybe you can't see what's going on here because you're in the audience, you're not typing. But for me, this is a very frustrating experience because my keys aren't having an immediate effect. I can't see the input taking place. So if we fire at the frustration meter and try it again, right? That's no fun. And a way that we have often tried to fix this is using a technique called debouncing. I can't type. Right, with debouncing, nothing happens until I stop typing, and then everything updates all in one go. And it means that the main thread stays unblocked and the app stays responsive, but we don't get any feedback, so that's not really a great user experience. Now, concurrent mode, or async mode, as it was referred to at the time, is the best of both worlds. The app updates while I type, but if it gets to be too much, then it will chunk up the work and yield back to the main thread. So the frustration meter stays green the whole time. But you might notice that as we get more and more complex, it starts to get a little bit slow to update the graph in the background. This is the same application implemented in Svelte. It's a very different user experience. I don't need to tell you whether that's better than the time slicing one. It's obvious what's better. And even with the frustration meter.
Can we add Inferno into this benchmark?
I mean, you're welcome to. You'll probably get a better result than you do with React, but Inferno is still a virtual DOM mechanism, and it's going to have some of the same fundamental bottlenecks.
You think Svelte is faster in this kind of benchmark?
I mean, you're welcome to try. And if you do it, then I will add Svelte and I'll tweet it out and we'll compare notes. So just to show you one more time, in async mode with React, it's nice at first, but it quickly gets a bit chunky. Now, it's obviously better than React without time slicing, but it's not clear to me that it's better than just having a framework that doesn't have these bottlenecks in the first place. The best way to deliver a good user experience is to be extremely fast. An analogy that I like to use is that of the internal combustion engine. The internal combustion engine is a marvel of engineering. Modern ICEs are incredible devices. Car companies have spent millions of dollars eking out incremental gains over the years. But then Tesla came along and said, well, what if we just change the underlying assumptions? What if we don't use fossil fuels at all? Well, then we have a different set of constraints. The average internal combustion engine has hundreds and hundreds of moving parts. The electric motor inside a Tesla has 2. An internal combustion engine, the best one in the world, has an efficiency of maybe 20–25%. A typical electric motor has an efficiency of 85%. So car companies are spending all this money trying to eke out these incremental gains from the internal combustion engine when actually the game has changed. So there are a few different strategies for speeding up our code. Breaking it up into small chunks and moving it around, like time slicing, it doesn't really speed up your code. It might make it feel faster, but it doesn't fundamentally change what's happening. A few years ago, everyone was trying to put their code in web workers to unblock the main thread that way, but no one does that anymore because it turns out it just doesn't work. You can't move the code around into a different place and expect it to have a meaningfully different result. You can't even rewrite it in Rust, it turns out. Last month, a guy called Nick Fitzgerald wrote a blog post about a library that he's working on at the moment called Dodrio. This is a virtual DOM implementation written in Rust and compiled to WASM, which is pretty mind-blowing. And the blog post boasted of best-in-class performance. Now, when you say best-in-class performance, it's like if you stand in front of the mirror and say Candyman 5 times. I will appear behind you. So I added Svelte to this benchmark. And sure enough, Svelte has better than best-in-class performance. Actually, the benchmark that it was using set timeout for the scheduling, which meant that most of the benchmark was just waiting for the browser's timer to run. So I changed the implementation to use promise resolution instead, which gives us a better idea of the raw DOM update performance. And we can see on the right that Svelte beats Dodrio by a larger margin. Now, I am bullish on Rust and WASM in general. I think there are a lot of good reasons why you would want to use Rust for different parts of your application. And I think that Nick has done some really incredible work here. But the virtual DOM mechanism is fundamentally not going to yield the best performance. There's only one reliable way to speed up your code, and that is to get rid of it. Be like Marie Kondo. Does this JavaScript spark joy? Now, when people like me talk about performance, we're often accused of having our heads in the clouds and not being concerned with the real-world impacts of our applications. And I find that so confusing. Performance is the most real-world thing there is. Stone is a company in Brazil that makes point-of-sale systems that you put your credit card into. And they tried building the interface for these devices with React and with Vue and with a panoply of other frameworks. And they couldn't get the results that they wanted. It was just too slow. The user experience was awful. They built it with Svelte instead, and it worked really well. So now, if you want to talk about real world, there are 200,000 these devices in the real world on the streets of Brazil running Svelte. These are low-powered devices that don't have the same amount of memory and CPU capacity that we have on a mobile device normally. MustLab in Russia is another example of a company that gets this. They make applications for smart TVs and things like that. And for them, Svelte is the perfect fit. It allows them to be extremely productive without having to worry about performance. And they're expanding Svelte now into other areas of their business, including a control panel for smart home automation. This is a trend that is only going to increase. The mobile web is not the new frontier anymore. The new frontier is the embedded web. Wearables, Internet of Things, smart TVs, in-car entertainment, all that kind of stuff. And the traditional JavaScript-first framework simply will not cut the mustard. We need something more powerful. But I'm done talking about performance. I want to talk about some of the other benefits that Svelte can give you. First up, accessibility. This is one of the things that developers all care about in theory, but something that we habitually get wrong because it's kind of difficult. Like a lot of people working in development, we don't have visual impairments very often. Often we have good motor skills and so on. And so it's difficult for us to appreciate how difficult using the web can be for some people. And I think that tools can really help us solve this problem. If you write markup that is inaccessible, Svelte will yell at you. Here we've got an image tag with a source attribute, but it doesn't have an alt attribute, which means that someone using a screen reader wouldn't know what was in this image, or someone even on a slow connection who couldn't download the image in the first place. And so down here, I don't know if you can see it at the back, there is a warning. It's saying, accessibility, image element should have an alt attribute, and it's pointing to where the image is. This is a warning that you would get in your terminal if you're using this in a conventional build setup. So we can add an alt tag, and the warning goes away. It's still compiled, but we got a warning. It will let you write markup that isn't accessible, but it won't respect you for it. Who works on a web application that doesn't have any styling? No one. Okay, good. So if styling is such a fundamental part of the web that we build, why do we use frameworks that don't deal with styles? They're unfinished. Svelte, on the other hand, because we're basically writing into a superset of HTML, we can use style tags right inside our components. We can have a paragraph tag that has a style from this P selector here. We haven't had to use classes. We haven't had to use complex namespacing schemes like BEM. We're just using the paragraph selector, and yet our nested component here, even though it has a paragraph, is unaffected by the styles in the parent component. And I can add some styles to this one as well. P, text transform, uppercase, right, and it only affects the child component, not the top one. The way that this works is it adds a computer-generated unique hash to the classes, and then it applies that to both the markup and the styles. Another cool thing that we can do if a framework understands both markup and styles is it can tell us when our declarations are not being used by the markup. And it will actually just remove it. You can see that that style there isn't reflected in the CSS output that gets written to disk. But it also gives us a warning so that we can remove that. This solves the problem that so many of us have experienced where you're terrified of removing any of the styles from your style sheets because you don't know what they affect, right? We've all experienced this at some point. CSS in JS is designed to solve this problem, and it does so pretty well. You can use CSS in JS with Svelte, but you probably won't need to because it has style handling built into the framework. Something else that we can do with Svelte is add transitions. If I toggle this visible Boolean, which is literally just that, then the element doesn't disappear and reappear, it doesn't snap into place. Instead, it transitions out gracefully. This is really good for like notifications and things like that. And the way that that is done is just by adding this transition fly directive to the element and then giving it some arguments. It's an object literal with one property, y. And that's just imported from this Svelte transition package here. Now if I toggle this really quickly, you can see that it actually reverses the transition smoothly and puts it back into the place where it's supposed to be, which is kind of difficult to do with some frameworks. Interestingly though, this isn't done with JavaScript. When the state changes, Svelte will calculate a CSS animation and then it will apply that to the element. Because CSS animations run off the main thread, this is more performant and more battery friendly, particularly on mobile devices, than if you're doing the animation inside JavaScript. And we can get pretty funky with this stuff. We can create our own custom transitions. This is a spin function which takes a node and it takes some arguments optionally, and then it returns an object with a CSS method which takes t, a value between 0 and 1. 0 is fully off the screen, 1 is fully on the screen, and it returns some CSS. So this is kind of like JavaScript in CSS. And then Svelte will take that, compile it to a CSS animation, and then it will play it on the element. So let's import spin from spin.js, and then down here we'll replace that with in, spin, and out, fade. And now when we play it in, we can go crazy. And we can use easing functions that aren't available in CSS normally, all that kind of stuff, and yet it's all done completely in CSS in a nice performant way. And we can get pretty complex with that stuff. I'm not going to show you all the code for this example, but I do want to show you conceptually what's happening. We've got a to-do list with two views of it. We've got one that is the to-dos filtered by the ones that have not been done. And then beneath it, we've got one that's filtered with all the to-dos that have been done. And as we toggle these, they move from one list to the other. But that's quite unsatisfying because that's not how objects behave in the real world. Our brains don't like it when things just disappear and reappear elsewhere on the screen. What we want is for these things to move gracefully to their new position. That helps us understand what's actually happening to the things inside the application. And so I'm going to take this label here and I'm going to add some directives to it. And now when I toggle these, they move out of the way cleanly like that. And again, this is all done with CSS and not JavaScript. This is the kind of feature that most frameworks don't include. And the reason for that is because in the JavaScript world, we're very conscious of bundle size. Often you go to a framework's marketing page and they will have the size of the framework right there on the front of the page saying, look, we're the 3 kilobyte alternative to React in Preact's case. And that's good because it's better if we can deliver less JavaScript to our users, but it means that we're restricting the number of features that we can include in our frameworks. But Svelte is a compiler. It doesn't have the same constraints. If you're not using a particular feature, like transitions or bindings, then we don't need to include the code that makes that feature possible. So you're always going to get the minimal subset of the framework's features. It means that we've decoupled feature set from file size, and that lets us, the Svelte team, be far more expansive in the kinds of features that we consider worth including in the framework. And that's good for developers, because as developers, we want all the features, but we just don't want to pay for the ones that we're not using. And what's good for developers is ultimately good for users. So Svelte is a low-level component framework, and you can use it to build pretty complex applications, but at some point you will need something a little bit more well-rounded. And so we have a project called Sapper. It's a companion project to Svelte. If you're familiar with React and you've used Next and Gatsby, those are frameworks that take the component framework and turn it into an application framework so that you get routing and code splitting, server-side rendering, and all of the features that make a modern web application easy to develop but performant. Sapper is like that, except with much less JavaScript because it's Svelte. You get automatic server-side rendering, you get automatic code splitting, all of that good stuff. There's a community project called Svelte Native, which will probably become an official project at some point, but it's still quite new. It's a community-driven project based on NativeScript Vue, and it allows you to build iOS and Android applications using Svelte. And beyond that, something that I really want to work on is Svelte GL, which would be like 3JS, but Svelter. You would use the same kind of declarative style to describe a three-dimensional scene graph, and then it would get compiled to the low-level underlying draw calls that would make that possible without all of the added bloat of a conventional WebGL library. So in conclusion, spreadsheets are pretty cool and we should be more like them. There's actually one more thing I want to say about spreadsheets, and that is how accessible they are. My wife is not a programmer, and after being with me for 15 years, she does not want to become a programmer. But she can do some incredible things with spreadsheets. When I look over her shoulder when she's working, my mind is blown at the amount of value contained in businesses around the world in these humble spreadsheets. Wouldn't it be wonderful if the tools that we use to build the web were as accessible as spreadsheets are? And that is one of Svelte's overriding goals, is to make web development accessible without sacrificing power for power users. My friend Eliza was working at Spotify and was using Svelte to work on a project, and her project manager was able to come over and work with and manipulate the component code directly in a way that would have been more intimidating if it was a JavaScript file. When all different people with different disciplines and different skill sets can crowd around the same laptop and work on the same piece of code simultaneously, that's when great things happen. So I hope that one day we'll be able to look back at Svelte and say that in a strange way, it brought us all a little closer together.